This video is about estimating percent, and the first thing I want to do is just a bit of review about exactly what percent is. So percent comes from Latin and it means by the hundred. So this part of the word means by the, and this part of the word means 100, which you may realize from taking French. Cent is 100 in French. So all a percent is it's a fraction that is expressed out of 100. And you might remember from fractions unit that you just did, a fraction that's out of 100 can also be really easily written as a decimal because it's hundredths, and we know how to write hundredths in decimal form. So I'm just going to pick an example. Let's imagine 27%. So 27% also means 27 out of 100, and it also means 27 hundredths, or 0.27. And if you wanted to go even further, this could be a ratio. It could be 27 per 100 that we might write like this. So 27% could be written in a lot of ways. You could write it as a fraction, or as a decimal, or as a ratio, or you could keep it as a percent. So remember, one thing that's challenging with fractions is you can't always tell the size of a fraction just by looking at it. So for these two examples, 3/4 and 4/5, you don't really know right away which one is the larger fraction, unless you do some math to make equivalent fractions. And that's what a percent really is. It's just an equivalent fraction that we find very convenient to use in math. So I'm just going to turn these into something that looks a bit closer to a percent. I'm going to make an equivalent fraction that will be hundredths as the denominator. So for 3/4, I'd have to multiply top and bottom by 25. And that's going to give me 75 100ths. For 4/5, I'll have to multiply numerator and denominator by 20. And that's going to give me 80 100ths. And because these are 100ths, I can write it as a percent. So 75 100ths is the same as 75%. 80 100ths is the same as 80%. If I wanted, I could also write it easily as a decimal because it's hundredths. I could have written 75 hundredths or 80 hundredths. So this is why we use percents. They're really convenient. It's a really convenient way to compare amounts. And think about it this way. Let's pretend you got 27 out of 41 on a test. That's an okay mark, not a great mark, but doesn't tell you exactly how well you did. If you wanted to know exactly how well you did and be able to compare it to other tests you've done in the year, you might want to convert it to a percent, and we'll do that on the next slide. Okay, so let's imagine you got 27 out of 41 on a recent test, and you got 36 out of 50 on the test before that, and you want to know whether you're improving or not. So it's very difficult to compare these two test scores because the denominator, or the out of number, is different. So in order to compare them, a percent will be really helpful. So for the top number, I don't think an equivalent fraction is going to work for me here. I need to do some dividing. Remember, this line in a fraction also really means divided by. So in order to convert this to a percent, we're going to start by converting it to a decimal, and we're just going to divide numerator by the denominator. And this is a wonky one. I don't really want to do long division on it, so you can pull out a calculator and divide 27 by 41. We'll see what we get. Okay, this is my calculator answer, 0.658536583568356. So this is a really super long repeating decimal. I don't want to have to write out the whole thing, so I'm just going to round to the nearest thousandth. So we're going to write this down as 0.659. And because it's in a decimal form, I can really easily also write it in a percent. So in order to do that, we have to multiply by 100, which you can do on your calculator, or you might remember just a trick. When you're multiplying by 10, it moves the decimal place over 1 point to the right. If you're multiplying by 100, it'll move the decimal point over 2 places to the right. So if you don't have a calculator on you, you're multiplying by 100, that's a quicker way to do it. So 27 divided by 41 is 0.659, which can be written as 65.9%. Okay, so now we want to see if I'm improving or getting worse on my math test. So let's make a percent for the previous score, the one on the bottom. This one we can use equivalent fractions because it's a nice, easy, round denominator. 50 is very easy to turn into 100. We just have to multiply by 2. So I'm going to multiply top number by 2, bottom number by 2, and that gives me 72 out of 100. If I wanted to, I could divide 72 by 100. I don't really have to do that because this is hundredths. I know how to write it as a decimal, 0.72. And if I want to write that decimal as a percent, it would be 72%. So, not good. It looks like my math scores are going down. I went from 72% to 65.9%. The key thing here is these numbers are much, much easier to compare than these scores here. And that's why percent exists. It's so we can compare amounts. It's a way to standardize amounts because not everything is out of the same denominator. So you can standardize it by making everything out of 100. And the reason 100 is chosen is because it's really convenient. It can be very easily turned into a decimal. You could also use tenths, but hundredths just works a little bit better for being more exact. So that's why percent exists. Now, next slide is going to be about how to estimate percents. So there are certain percents that we call benchmark percents. They're very easy to calculate, and we can use them to estimate nearby percents. So here's an example. 50%. So what 50% actually means, if we have 100 of something, 50% of it would be 50 out of that 100. So I'm just roughly shading in 50 squares out of 100 on my 100 grid. So that might look like something else to you. That's also 1/2. So what this tells us is if I'm trying to estimate 50% of something, or even a close by number like 52% or 55%, I can reach that estimate just by dividing by half or dividing by 2. So if I had 122 apples and I had to give away 50% of my apples, I want to know how many I'm giving away. I could divide that number by 2. I'm running out of space. Let's write that somewhere else. And that would tell me what 50% of 122 is. So let's just quickly do that. 12 is divided by 2 is 6, 61. So 50% of 122 is 61. And I just reached that by dividing by 2. So anytime you see 50% or something close by and you want to estimate, just think about half, half of that amount. And you reach half of an amount by dividing by 2. So 25% is another useful one. 25 is half of 50, so you can reach 25% if you want to divide by 2, and then divide by 2 again. That's a lot of division. Another way you could do it is just dividing by 4. The reason you can do that, 25% is also 1/4. And you can figure out 1/4 of something by dividing by 4. So, for example, if you had $6 and you only going to be able to keep 1/4 of your $6. How much would you get to keep? Well, it would be 6 divided by 4. So let's do that division. 4 goes into 6 one time. 4 goes into 20 5 times. So you would get to keep, it's very messy here, hopefully you can understand it, $1.50. So $1.50 is 25% of $6. It's also 1/4 of $6. So the trick for 50, if you want to find 50% of something, divide by 2. If you want to find 25% of something, divide by 4. Okay, some other useful percents for estimating are 10%, 5%, and 1%. So 10% represents 1/10 of something. So let's imagine the number 282. You have 282 of something. I don't know what it is. You have 282 lobsters, and you want to get rid of 10% of your 282 lobsters for some reason. How many lobsters do you need to get rid of? So what's 10% of 282? You could find that by dividing by 10. Or one really quick way you could do this is when you divide by 10, it's the same as moving the decimal place over one place value. So 1/10 of 282 would be 28.2 lobsters in this example. 5% is related to 10% because 5% is just half of 10%. So 5% would be half of this amount, which you may have to divide to calculate, or you may be able to just figure out. Half of 28.2 is 14.1. So if I needed to give away 5% of my lobsters in this example, I would give away 14.1 lobsters. And then 1%, you can follow a similar rule as 10%. It's like 1/100th of something is 1% of it. So you could divide by 100, or you could move the decimal place over 2 place values. So 1% in this example, my lobsters would be 2.82 lobsters. Another useful percent for estimating is 30%. 30% is approximately 1/3. Actually, 33% is closer to 1/3, but 30% is a nice round number. So because 30% is approximately 1/3, you can find 30% of something by dividing by 3. So my example is 99, 99 pennies, I guess. So if you have 99 pennies and you had to separate 1/3 of them, be 99 divided by 3, which you may be able to do in your head. You may have to divide out. 99 divided by 3 is 33. So 30% of 99 is approximately 33. All of the examples I used so far were ones where you had a total number of something, and we had to find out percent of that total. So, for example, if you have 100 cars and you want to find out how much 25% of that amount is. But we might estimate in the other direction too, where you have a fraction and you want to estimate what percent that fraction represents. And you can use those same benchmark percents. You do have to think about it a little bit and use some reasoning. But for all these are kind of wonky fractions, but we can use estimation to figure out what percent they would be close to representing. So let's start with 27 over 52. So I know 27 is close to half of 52 because 25 is half of 50, so 27's got to be close to half of 52. Since it's close to half, I know that 50% represents half. So this fraction, my estimate would be it's approximately 50%. Not exact, but approximate. What about the next one? 2 over 211. So 2 would be approximately 1/100th of 200. My denominator is close to 200, so the closest percent here would be 1%. Remember, 1% is 1/100th of something. So that's why 1% works for this. If it was 2 over 200, it would be exactly 1%. It's not. This is just an estimate. So that's my estimate for 2 over 211. 30 over 88, that's a tricky one. But I know that 88 is close to 90, and I know that 30 times 3 is 90. So 30 is 1/3 of 90. So 30 is close to 1/3 of 88. So because this is a third, I'm just going to say 30% is a fairly close estimate. 11 over 42 is the next example. I think 10 over 40 would be exactly 1/4. 11 over 42 is close to 10 over 40, so it represents about 1/4. And 1/4, that should make you think 25%. It's approximately 1/4. And 9 over 90, so I know 9 times 10 is 90, so that tells me 9 over 90, that's 1/10. So for this estimate, I should be thinking 10%.